We left off last time. I accidentally deleted this stuff. So we have some words there. And use Excel to enter data into the spreadsheet and have it generate the line of fit, the equation, and the correlation coefficient for the Old Faithful problem. So we're going to go back and look at the Old Faithful problem. And we are talking about the line of best fit here, not just any old trend line, but when you use a computer software package like Excel, or in a little bit we'll also look at the calculators, that's going to generate the perfect line of fit for you. So that's why it's called the line of best fit. It's not just any old trend line anymore. And then we want to predict the interval for the next eruption after a 7.5 minute eruption. So let me bring up my spreadsheet. Actually, let me go back to the data here. And I got to go one more, I think. Yep, here we go. So again, I accidentally deleted everything, but here we are. So the Old Faithful problem, this is our data. We said that this duration was the amount of time that Old Faithful erupts for. And this was our independent variable. Then the interval of time until the next eruption is this guy here. That's my dependent variable. And then we made a scatter plot. And we came up with an equation. What was that equation, just so we have it written down? 15x plus 25. Okay. And then, can you use this equation to predict the length of the next eruption? We said no on that one because this only tells us how long until the next eruption, not how long the next eruption will be. So we need to understand that difference. And then we also came up with an answer. Use your equation to predict the interval to the next eruption for a 7.5 minute eruption. What was our answer? I think it was like 138 or something like that. 137.5 minutes. Okay, so that was our prediction for the next eruption of Old Faithful. Now what we're going to do is use Excel and enter the data into Excel and see what Excel comes up with. So I brought up Excel and I've already entered in the data. And I want to talk about a couple of things on here. I know most of you have used Excel before, but just in case you haven't, well actually all of you have, I know you all have. So the duration here in minutes goes along with which variable? The x variable. And the interval in minutes goes along with the y variable. So I'm putting the independent variable in the left column and the dependent variable in the right column. That way when Excel graphs it, it will put this one, because that's what Excel does, it puts the left column on the x-axis and the right column on the y-axis. Okay. Notice that the way that I labeled that is duration and then parentheses minutes. I'm putting my units up here so that I don't have to write it down here. If you put it up here, it's understood that that's following through for the entire column. So I've just repeated that table that they were given to us. So now what I'm going to do is to create a scatter plot, go up to insert, and then we have scatter plot sitting right there. Then you get these 5 options right here. We're only ever going to choose the one with just dots. A scatter plot is just dots. So probably be helpful if I selected my data first. So let me get rid of that. I'm going to select my data now and then go to insert and scatter plot and then just dots. And there's my graph. Looks pretty much just like the graph that we came up with, except probably a lot more accurate. Okay. Now what we're going to do is up here in this little window up here, there's a bunch of different types of scatter plots that we can graph, just like you have different types of bar graphs that you can graph. I'm going to drop this window down and open up all of the options that they give us. Each one of these options is still a scatter plot, but they plot the data a little differently. So if you notice, there's also differences outside of the dots that are plotted. Like on this one, we have a title, axis labels, our dots, and a legend. Looks pretty good. Let's try that one. So here we are, title, axis labels, dots, and our legend. Okay? Now if I pick a different one, that's actually the one that we're on right now. If I pick a different one, you see that line right there? That's going to be my line of best fit. But there's no title on it. So now I have that. It also didn't give me an equation, which I don't like. I like to see the equation. I can make it calculate an equation for me. If I choose any of these, they'll all come up looking like the little template that they show. But this one right here has the title, it has the axis labels, it has the legend, it has the line, and then you also see this, looks like an fx there. That's f of x, that's function notation. That means that it's going to give me the equation. And sure enough, there it is right there. So the equation that Excel came up with was 14.095x plus 28.44. The equation that we had was 15x plus what? 25. Is that pretty close? What we came up with is pretty close to what Excel is calling the best possible line of fit. And we're going to get to that. So we can use Excel to do this. Now your project that you're going to be doing pretty soon is going to be done on Excel, and you're going to be making scatter plots, and you're going to want to pick this graph. And then from here we can change our title, we can change our axis labels, change our scale, and so on. Okay? But that's the important thing we need to know. So the equation that we came up with, 14.095x plus 28.44. I'm going to write that down. 14.0 what? 95? Something like that. X plus 28.44. That's my equation from Excel. Now I want to do the same thing. I want to evaluate this thing for an interruption that lasts 7.5 minutes. So that means I'm going to enter 7.5 in here. So 14.095 times 7.5 plus 28.44. Enter it into your calculator, and what do you get? 134.15.153. Okay, and that's minutes. So compare that to our answer that we got from our equation. Really close. So we did a really nice job with the equation that we came up with. It was very close to what we actually should get. This is the best possible answer right here. So if you're using some sort of computer software, everybody's going to wind up with the exact same answer. They're going to wind up with the exact same equation because that is the best possible line. And Excel will always give you that as your answer. Okay? So using a computer software program is better than doing it by hand because you wind up with a better answer, more accurate. Okay, I'm going to do the exact same problem again, except this time we're going to use our calculators. So on our calculators, we need to turn them on and go back to the home screen. On our calculators, we can create a spreadsheet. If you notice the icons down at the bottom, and I know that on the screen here we can't really see that very well, but that icon right there looks like a grid. That is a spreadsheet. So let's open up that, and we'll wind up with a spreadsheet here. See if I can make this look a little better. Now this spreadsheet is not like your Excel spreadsheet. On Excel, you can enter a formula into any cell that you want. These calculators are not as powerful as your usual computers that you use, so this spreadsheet works a little differently. You see that gray bar has a diamond at the left side, that gray bar? That is the only column or the only row that you can enter formulas into. Anywhere else, you can only enter data. And we are never going to use that row. Never type anything in there. If you do, you're probably going to have to clear the memory on your calculator and start over completely. So we're going to skip that row entirely. At the top, we're still going to enter in the name of our data for the first column. So we're going to call that one duration. You can actually type in the word duration, D-U-R-A-T-I-O-N. Press enter. Then move over to the second column, column B, and type in interval. These are the names of the variables that we're using. So now you can probably guess that what we're going to do next is enter in the data for the duration column based off of the Old Faithful problem. So it's going to be 1.5, enter each time. Then 2, 2.5, and so on. Make sure you hit enter on that last cell. When you're done with the duration column, scroll back up, and next to the 1.5, start entering in the interval column. Press enter each time. When you type in your 100, make sure you press enter on that one as well. A lot of people will forget to press enter, and therefore your calculator will give you an error when you try to do what we're about to do. So make sure you press enter there. So the next thing we're going to do once all your data is entered in is go back to the home screen. So press the home button, which is the on button, same button. And what we're going to do now is move over one to the right. You see that purple icon next to the spreadsheet icon. It says data and statistics underneath. We just entered in a bunch of data. So you're going to click on that one and it will insert a scatter plot for you. Now your dots on your calculator will probably look completely different than my dots on my calculator. That's because we haven't told the calculator which variable goes where. It's not like Excel. Excel assumes left column x-axis. This calculator does not. So what we need to do is mouse down to the x-axis where it says click to add variable. So we'll click on that, and which variable is supposed to go on the x-axis? The duration. So we're going to click on duration. And it organizes our dots for us along the x-axis. Then notice that the y-axis label disappeared. So we need to mouse over until a little box shows up where that label should be. And then click. And then obviously the other variable is going to be intervals. So we press down and click on that one, and it automatically gives us the scatter plot. Notice that the scatter plot that we made here looks exactly like the scatter plot that we had on Excel. Okay? Everything is adjusted for us nicely. We have scales on the x and y axis. We have the label sitting there. We have all our dots. So this is a really nice tool to have, and you can use this on your homework. So now what we want to do is make the calculator give us the best possible line, the best line of best fit. In order to do that, we're going to have to learn a new math term. And anytime you want the calculator to do something for you, you're usually going to press menu. So when I press menu, I see a bunch of options. I want option 4. It's analyze. You can scroll down to 4, you can mouse to 4, you can press the number 4. Either way, you get a bunch of more options. The next option that we want is called its regression. A regression is a mathematical term for give me the line of best fit, basically. Okay, so it's just a new vocab word. So we select regression, and then it gives us a whole bunch of different types of regressions that we can pick from. Which one do you think we probably want? Yeah, the top one. It says show linear, and then what's that mx plus b? Slope-intercept form. So we're saying, give me an equation for this in slope-intercept form. So I can click on that or press enter, and it gives me the equation for my line. Notice that it's in slope-intercept form, and also notice that it is exactly the exact same thing as what we came up with in Excel. Because both programs give me the perfect line of fit. So now from here, we write down this equation, and then analyze like we just did with the other equation that we came up with from Excel. So this process that you just learned is something that you can do on your homework or on quizzes and tests, okay? If you remember how to do it. This will give you the best possible line. While we're at it, I might as well show you that you can also use the graphing calculator to graph equations for lines. So if I wanted a line that had a y-intercept of -2 and a slope of 5, what would my equation be? I want a slope of 5 and a y-intercept of -2. It'll be 5x minus 2, right? So let's type that in. The cursor is already down at the bottom, so just start typing in 5x and then minus 2, not the -2, the minus 2. Press enter, and there's your line. There's all kinds of things that we're going to learn how to do on these calculators with graphs. But for now, That's how you can graph a line. Now let's say I want to graph another line, and I just want to use the exact same grid that I'm given. Press Tab, and that'll bring the function box down at the bottom. Open up again. Notice that we are using function notation here. The first equation said f1 of x. This says f2 of x. It just means that it's the second function. Okay? So they're using function notation because that's the better way to call your equations. So let's make another one. Let's go like negative 1/3. So negative 1 divided by 3, x, and then plus 4. Press enter. And it gives you that line. And notice that it is a different line, so the calculator gave it to you in a different color. The equation that you typed in is also sitting there. The f1 of x was red, just like the line was. The f2 of x is kind of written over the top of the f1 of x. That's okay, but it's in green. And so on. So pretty soon we're going to be using calculators more, but I wanted to introduce those to you now so that you can see that you can also use the calculator to graph. Back to Excel real quick. We have this letter right here, r squared equals 0.9669. What that is something called the correlation coefficient squared. So if you look back at your vocab, it said line of best fit and correlation coefficient. If I move this down and change back to where we were, correlation coefficient, what do we have written down there? How well one variable relates to the other. The correlation coefficient is usually called by the letter r. Well, this is r squared. So technically we don't have the correlation coefficient sitting here. But this r squared value does tell us how well the two things are related to each other. The closer to 1, the number will always be between 0 and 1. The closer to 1 this number is, the more the data is related. The closer to 0 that number is, the less that data is related. So in other words, the closer to 1, the better my equation is. The closer to 0 this number is, the worse my equation is. So if it's close to 0, then you could say probably there is no correlation at all. If it's close to 1, then there is a very strong correlation. Would you say there's a strong correlation here or not much of a correlation at all in this problem? Very strong. 0.96 is incredibly close to 1. So that's what that r squared value means. And like I said, you're going to be using that on your project hopefully, or you can anyway, you don't have to.